Thanks for the introduction. And really, this is the last talk. Hopefully, we can have some interesting discussion here. Before we start, let me ask you a quick question. How many of you are from the, I know you are all working AI, but how many of you are from the security industry? Oh, good. So looks like we have some experts here too. This talk actually, this is just really looking at a different side. And, my goal is especially given most of the AI developers, right, just to try to walk through some of these, known risks and vulnerabilities of using LLMs, and also want to share some of the empirical experience about how to build a, relatively comprehensive LLM protection solution. So a quick intro of myself. As you just heard, now I'm working in Traceable as the head of AI ML and also VP of engineering. So Traceable AI actually is also kind of like a Series C startup, which is specifically actually is the industry leader in the API security space. So we have built actually an API platform to give the complete visibility of API security, for discovery, testing, runtime protection. And before joining Traceable, actually I have been spending most of my career just applying AI ML to different emerging cybersecurity challenges. So you can see actually, I started with network security, then to cloud security, and no surprise, Gen AI will be the battleground for the, for the cybersecurity in the very near future. So, I try to put some of the Disney theme behind this. And I won't spend too much time on this. As you know, like a generative AI technology empowered by this large language model, just similar to the, to electricity, is expected to really revolutionize almost every industry, right? Ranging from healthcare, education, telecommunication, manufacturing. So there's so many talks, covering all different, really the potential of the generative AI. So that's the reason in my talk, actually, that's really the light side. But I want to actually spend a little time to just start to think and at least, bring some awareness of the dark side of the generative AI. So when we talk about the dark side, there are actually two different perspectives. You can think all aspects. One is really the attackers can really leverage in the generative AI technology to really empower them to even make them more effective for the work they do today, right? So they can automate a lot of tasks. They can introduce some new kind of like a more complex attack, like a spear phishing. And also deep fake probably is another growing concern, as you probably already heard of. So actually, I'm going to cover the second piece, which is use LLM as a new attack surface. You can look at from my career, when there's a technology, emerging technology shows up, it takes a little bit of time for the technology to be adopted and really become the mainstream, right? So it happened to networking for the Web 1.0 or 2.0. Then network security becomes the mainstream probably like 10 years later. So it happened to cloud. Cloud started in 2012. Then cloud security did not become the mainstream until probably 2016 or 17. So there's always this, you can think like a 5 to 10 years gap between an emerging technology showing up till really the technology becomes the main battleground for the security. So Gen AI is not going to be, it's not surprising Gen AI will take the main stage for the cybersecurity in the near future. Just given the really Gen AI probably is the fastest adopted technology so far. And given all of this like widespread impact as we talked about, this is no surprising. This will be the target for the attackers. Just because when there's all of this, you can think about the fintech applications, banking applications, consumer applications, enterprise applications built on top of the Gen AI technology. the technology itself will become the target. So we're going to talk about really actually this is recently actually published early this year by OWASP. First is OWASP. OWASP stands for Open, I think, a worldwide application security project. This is an open source community which actually publishes these free articles and documents and even tools to help specifically for the application security space. So this list just covers the most critical, so far as what we are aware of, the most critical top 10 risks and vulnerabilities of the large language models. This actually is also a collaborative effort over thousands of the AI developers, security researchers, and different experts. So if you look at this list, I'm not going to drill down into each of them, but the interesting is this actually covers the whole life cycle of the LLM. From the, you can see there's number 3, training data poisoning. This is really the first step of the model training, the data collection and the model training, right? So then to the model development work, then to the model deployment, like a production deployment, like a model theft, is really a threat to the production stage. And also, there's all various type of really the model kind of application integration stage. Like say, prompt injection is a good example here. So these are just the initial list of the top 10. And this list is supposed to be refreshed every year. I'm not surprised if there's a new type of the attacks, because security is showing up in the next year or even in the next few years. Because security industry, to a very large extent, is actually driven by the attackers, then the defenders. They always come with a new type of attack, then the defender will follow up. So this is another good graph, actually explain how different risks so far map to the life cycle, as I mentioned, for the whole LLM model development work and also the application development work. This actually is for the applications which leveraging the third-party LLM models. If you look at the top, so there's actually, if you build an AI application leveraging the third-party application, or third-party LLM models, then there's the immediate challenge of this called the supply chain risk. Where do you get the model come from, right? Are you going to unintentionally or just accidentally actually use some of the open source model probably on Hugging Face or anywhere, which are embedded with some of the threat knowledge? So how do you really, evaluate and find, test this beforehand, before you put in your application? So this is a good mapping, and I also like this graph. This is more like for the companies who are building their in-house self-hosted LLM models for their applications. You can see this actually even ranging the risks, actually ranging from the supply chain side, from the data pointing side if you train your own model, and also from the ML ops, right? So, and also there's a bias introduced at the application phase. So the key point here is, the risk and the vulnerability to LLM models is not just a point, just a small pinpoint. It's really ranging across the whole life cycle of the LLM models. And there will be just more and more of the new type of attacks showing up, given the wider adoption of the model. So next, actually, I just want to use one simple example. I think, I guess probably most of you heard of this new word called prompt injection, right? This was specifically created for LLM models. This is just a typical type of, this also is one of the top 10. So this is by definition, prompt injection is really the attackers try to intentionally craft some malicious prompt to work around the security checks and the restrictions of the model to get some unintended output. So the consequence of the prompt injection normally can range from, like, say, sensitive data leakage, right? You're leaking some of the business secrets, the IP information, or even any of this PII, any of the sensitive information which are not supposed to be exposed by the models. But it can also cause a lot of other like hate crime, like some of the bias or some other kind of even like a broader impact problem here. So I list some of the simple examples at the bottom about the simple examples of prompt injection, how people do. Like you can read this sentence very easily. So this is still very straightforward. You can just look at the keyword and say, oh, ignore something, or pretend, or assume, right? Try to give some of the kind of information to the model to let the model work around the security checks. So this kind of simple prompt, malicious prompts, it's actually, it's pretty simple. It's pretty straightforward, and also it's not. It's understandable that we can detect them in a pretty straightforward way. You probably don't even need an LLM model. You just need some kind of pattern recognition or NLP model to detect this kind of simple prompt injection. But let's look at another example. This is called a multi-turn LLM kind of jailbreaking. This actually is published from Microsoft Research recently. So if you look at this example, in this example, it's still prompt injection. But in this example, actually, they tried to ask how to make this weapon called Molotov cocktail. And because of the security guard actually built into the guardrail, built into the LLM models, I think you can see from the left side is ChatGPT and the right side is Gemini. So actually, they built this first level defender. And when you ask how to make these dangerous weapons, the answer is no. I cannot give the answer. But in this case, the attacker just used multiple iterations, you can see, use a different kind of like conversation to work around. And finally, at the bottom, both actually of these models, actually these are probably the most secure foundational LLM models. And finally, they actually give the unintended content at the end. So to detect this kind of multi-turn LLM kind of jailbreaking or prompt injection, as you can see, imagine, it's way more complicated than just the previous example, right? You have to, not because you have to understand the whole conversation, understand the context, and also the intention, right? It failed, the first one is very straightforward, but how do you really understand the intention of the following 3 or 4 prompts? And it can be longer and longer, right? So this is always, kind of a cat and mouse game. The attack will be more complicated, and the defender has to catch up. So these are just, I won't go through all of this. These are just, not surprising, some of this LLM kind of like vulnerability already, showed up on the headlines. This is from Microsoft Bing, and this is from Air Canada. And I think we should just expect to see more and more of this in the future. Okay, so let's come to the next chapter, how to really protect this. So I'm going to still, this is an emerging industry called, you can call LLM security, Gen AI security. And there's actually a lot of the companies, probably more than 2,000 of the companies, startups, big companies, working in this area, just because everyone knows this is going to be, a real threat to the whole, to all of the industries that, or all of the enterprises that leverage LLM technology. And this will become bigger and bigger as we discussed. So I just kind of like give some overview of what is the solution we have built at in Traceable to protect LLM applications at the API level. So the first question is why API? I don't know if you remember, if you heard Jisheng Wang from NVIDIA when he gave his keynote talk in GTC in March early this year. He actually mentioned one interesting note is most of the applications in the future will be LLM applications. And all of the LLM applications will be just calling APIs. So it's most probably when you develop a new LLM-based application, you are pretty much calling the API of another LLM application. And this chain can be not just one hop, can be multi-hop there, right? So API is really, API level gives the best visibility, of all of the interactions across all different type of the, you can see I list all of these different scenarios where LLM applications can be used, like for example, third party. So your employees can definitely leak potentially like proprietary information by querying these third party LLM models, right? Definitely hopefully in the unintentional way, more like the negligent kind of user case. And these LLM models can be, if you want to train your own models or fine-tune your models, you probably need some microservice to do that, right? And also, if you build an LLM application in your, or LLM model in your application, you probably need to look at the SaaS, the API calls from the SaaS. So the first thing to build the LLM security solution is to deploy this comprehensive agent framework across all different environments, applications, even API gateways, anywhere that user can be your employee or really the customer may interact with your LLM-based applications. So this is the first step. Actually, in Traceable, we spend almost 4 or 5 years of the time just building this kind of continuous, building more and more of the agent framework to coverage different kind of environments to collect the data and send the data to a data lake. When all of the visibility data of the application and the specific LLM-driven application get collected and sent to a centralized place, then there are at least 3 different aspects you need to, we need to do to really build this solution. The first is the discovery, because these days with a lot of the in-house fine-tuning, in-house built LLM models, it's not saying any communication has to go to OpenAI to use the LLM. You can have some internal applications, all of this. So how to discover all of the LLM communication with all potential LLM-based application? That's the first challenge, because you have to know where it's happening before you can really run any of the protection. So once you discover all of the different scenarios of the LLM kind of applications, then the second actually is testing. So this is proactive versus reactive. Protection is always reactive. And you want to test against all of these known vulnerabilities, against your LLM model application before you release this in production and make this customer facing. So how to really do a more innovative testing for the LLM applications? This is also an industry level kind of challenge. I think there are different companies working on that. And I'm going to really focus on the last piece, for this talk, is the runtime protection. So the idea of runtime protection is you look at the traffic going through the API calls, and you look at all of this vulnerability we talk about. For example, prompt injection, the sensitive data leakage, right, and toxic response. These are really the vulnerabilities you want to detect and stop if you see any of this pattern in the kind of API traffic. So this is what we call the runtime protection. To do this, actually, we build, this is the other way. It's how do you fight against the LLM? This LLM attack, it's use LLM to protect LLM. This is, I think, the answer looks like it's a little bit funny, but this is really the approach I think we are following. So the idea is, we kind of fine-tune. I'm going to talk more about the fine-tune process later. So we fine-tune individual expert model for each type of the vulnerability. This known vulnerability, that's the reason it's very important that you know what your target is, and use some of the labeled data to fine-tune a model for each expert model for each of them, And then we build this more like a MOE mixture of the expert layer on the top. Why do we have to do this rather than just training a bigger model, with all of the knowledge? There are two reasons. One is definitely the cost. This can dramatically reduce the number of the parameters in that neural network you need. If you have to put all of the vulnerabilities into one neural network, it's sometimes orders of magnitude bigger than each of the individual model. So that's one. The second actual reason is the latency. Because remember, we are doing the runtime protection. We really inspect every LLM API calls. So, and we are detecting those potential attacks like a prompt injection, and we are stopping in line. We're stopping them in line. So think of the latency for doing all of the work. Probably is just the tens or hundreds or a couple hundred milliseconds. That's all of the budget you have. So all of this limit our potential capability of using large size or foundational models, all of this, because of both the cost and the latency kind of considerations here. So this actually, I don't know how many, actually I'm looking around to see, how many of the companies or how many of this, especially enterprise-driven companies, are really building their in-house LLM models through fine-tuning. So yeah, it's very easy when people talk about agent, talk about multitask agent. All of this are really very how to say, these are very powerful. But how to really build this with a good balance of the cost, efficiency, and more importantly, the data privacy. Through your proprietary kind of like application or proprietary kind of technology. I think this is something, it's still industry level challenge, how to balance all of this. So one thing, I won't go through the whole steps here, but one thing I want to specifically point out, I think people may underestimate. One of the biggest challenge, probably the biggest challenge in all of this, is guess which step has the biggest challenge? No, actually is the first stage. Because the other question I normally ask during the talk, do you know how many of the open source models shared on Hugging Face these days? More than 1 million. Check. Actually, that was a 2 months old number. So there's so many of, when you think of open source model, a lot of people just think of Llama, Gemini, all of this. But actually, there's tons of this fine-tuned and multi-phase fine-tuned open source model here. So actually, one challenge we started is, if you want to fine-tune your own model, you want to, based on all of these parameters, model type, model size, all of this, you want to find the most appropriate model, the open source model to start. But just to find that out, one, or let's say you want to find like 3 candidate models. Find 3 out of 1 million, it's not an easy task. So we end up spending, because my team actually are all very experienced data scientists. Training the model, doing the fine-tuning, all of this actually pretty like a textbook kind of work for them. But we realize actually how to really, this has never been a problem before the Gen AI or LLM, because they are only maybe before the Gen AI, there are probably just 24 of the models you can select from. Most of people use not more than 5 models, most of data scientists. But when now you try to leverage the prior knowledge learned from the pre-trained model, but suddenly you have this big number of the candidate you want to choose from. So it ends up actually we spend most time to build this called model testing and evaluation framework. Because each of these model is specially built for your purpose. Your evaluation and the selection criteria may be different than any others. So I see this is a really industry level challenge when people start to fine-tune their own model. So this is also, these are some of the efficacy numbers. And don't just look at the absolute value, because this also we have done multiple fine-tuning of them. So these are not the latest. The only thing, this by the way is a comparison of our proprietary model against the open source LLM tool called the LLM Guard. So you can see by just doing 1 or 2 rounds of fine-tuning, we can easily get a lot of the efficacy gain. But the interesting thing I want to point out, if you look at the last 2 rows here, so we actually we use actually Debota in this case as our foundational model. And we actually tried the base and the large. You can see there are about a 3x difference in terms of parameter numbers and also the model size. But the interesting thing is if you look at the efficacy numbers, don't look at the absolute value, but the relative value. Using a large 3x larger foundational model or the open source model for fine-tuning, actually the model size did not help much if you just compare. Why? Just because all of these open source models, especially security is a pretty niche use case. Those kind of foundational models may see the data of security across the internet, but these are definitely not the most part of the knowledge they learn, right? So if you think of this 700 billion, parameters in, say ChatGPT 3 or 4, how many of those are really trained for this part of knowledge? Very, very small portion, right? So you don't want to take, that's exactly the value of the fine-tuning. So
wrap up?
Yeah, this is the second of the last, yeah. I'm not going to go through the details. So from our empirical experience, we believe fine-tuning, especially for any of the enterprise building your own LLM-driven applications, fine-tuning not the large language model, fine-tuning the small language model probably is the most practical way to go for the good balance of, because they can actually achieve comparable performance and efficacy numbers with a lot of the savings on the cost and more importantly on this privacy. You don't have to give up your data, So anyway, to summarize, so there are 2 aspects, if you remember, about this, the dark side, and this are just our answers, corresponding to them. So thank you, everyone.
Thank you. We're over time, but if anybody wants to ask a question, feel free. Otherwise, we just got ice cream.
I don't want to take too much time.
SOC 2 compliance and all of those regimes, do you see those also changing to accommodate these new surface areas of attack?
Yes, actually in both ways. We are also, because we are selling to enterprise, we have to be SOC 2 compliant ourselves. So first is really for the 2 sides. One is like if you train your model, how to be SOC 2 compliant for the data kind of privacy for all of this perspective. That's one. Second is how do you be SOC compliant? And the second is how do you build a solution to be SOC compliant specifically for the LLM part of your product. Yeah, so SOC 2 definitely also need almost everything related to security, compliance, regulation, all of this need to catch up with LLM, like kind of applications there.